Hello, professor and classmates. My name is Zhangni. Now I will give some short descriptions about my paper comparison of distributed systems for stream processing. The ability to process continuous data streams is becoming essential for today's data-driven companies and organizations. For the last decade, stream processing systems have emerged at an amazing rate. So it becomes necessary to form some guidelines for identifying the most suitable stream processing systems in certain use cases. In this paper, I focus on 4 popular frameworks, including Spark streaming, Flink, structured streaming, and Kafka streams. Since the performance is one of the most important factors for choosing a system, in this paper, I conducted an experiment for comparing the performance. In the experiment, 4 metrics are considered: the latency, throughput, memory utilization, and the CPU utilization. The experiment is conducted in the CSE cluster with 6 machines, and I designed a pipeline with in total 6 stages and 2 workloads. With the experiment, the code are divided into 2 parts. First part is the data stream generator with SBT compare and run. With SBT compare and run, we could publish the data by 2 Kafka topics, and in the benchmark in the benchmark folder, different systems holds different subfolder. For example, in the Spark benchmark, there is a Spark traffic analyzer Scala file with SBT compare and run. We could run the file, and with the program running, we could collect the related performance data. And we can see the whole result in our report. As you can see in this chart, it clearly shows that due to the micro batching architecture design, the Spark streaming and structured streaming has a disadvantage in the latency, and the event-driven systems like Flink and Kafka streams hold a better performance when considers latency. And in the next 2 chart, we can see that the Flink and Kafka streams take higher CPU usage, and the CPU usage has a linear relationship with the throughput. So if we don't take the latency into consideration, the Spark streaming and structured streaming will have a higher throughput, but with tighter latency considerations, Flink always had a better result. And in the last part of the paper, I also discussed some other questions we need to consider when picking up a right system. For example, who built it? Is accurate order important? What is the ecosystem like? And what if the message get lost? When taking all the questions into consideration, Flink and Kafka streams will not always be the best choice. And if our system needs high speed to process the data, of course we can choose Kafka and Kafka streams and Flink. But if our project needs to conduct it need many batch API processing, and need much batch processes, and we need tighter relationship with machine learning. Spark streaming and structured streaming are a great choice. So in short, when talking about which stream processing system to use, we should give our answer case by case.